Yo, what's up, what's up, what's up? Welcome back. Today we are working on our QR code scanner. We have this like version of the QR code scanner that kind of works on idealized cases. So small QR codes, perfectly axis aligned, perfect lights and darks, perfect, yeah, like basically like the type you would see before you print it. And now what we want to do is we're starting to look at how do we go from a noisy, real photo of a QR code which maybe has like shadows and imperfections. How do we go from that into something that we can scan? And so 2 days ago, what day is it today? Wednesday. So on Monday, we were looking at we built this like little debug UI. So we made this like really shitty version of a QR code. So we took like some photo from the internet and we like cranked up the noise and added the shadow to simulate like, you've got a bad phone, it's dark in the bar, there's lights on and shadows, whatever. And we built this little debug UI, which I think actually isn't running right now. Hold on. Zig build and run this. Okay. And so what we can do here is we can like select a region. It will take that region that we selected, it'll blur it a little bit, and generate this histogram over here. And then we started working on like the world's worst like binning algorithm. So the idea is that depending on where you've selected, what is considered dark and light is going to change, right? Down here in this region, you're going to have your lights kind of in this area, your darks in this area, where the histogram is kind of indicating like the stuff on the left is number of pixels that are dark and the stuff on the right is number of pixels that are bright and everything in between. And so where it gets kind of interesting is like, these guys are going to have kind of different ranges in the different areas of the image. And then also like across this boundary of the shadow, what is considered light and dark is kind of confusing. And so what we want to do is we want to figure out like, how do we like categorize these lumps? So what we're doing with our first algorithm was we just look at the tallest thing in the histogram and put it into a clump. And over time, we start to generate more clumps. So we have to like figure out some sort of merging strategy, which we haven't done yet. And so, yeah, I think that's what we want to work on first is how do we like kind of turn this into two distinct categories, light and dark. And so I think that we have to kind of fix this algorithm a little bit. I think that we probably want to like remove some of the noise on the histogram and try to get it to be like a nice little nice and round so that our algorithm can do a little bit better. We need to figure out if there are more than two bins, right? Like in this scenario, we should end up with like 4 categories, right? How do we decide which ones are light and which ones are dark? Maybe it's by limiting the region so that we only need to consider 2, right? Like if we're looking at a pixel in the center of this region, maybe it's good enough that over here it biases towards the light side and here it biases towards the dark side. Maybe that's fine, maybe it's not. Once we've kind of figured that out, then we can just start trying to like actually apply a binning algorithm to this picture. So what we want to get at the end of this is we want to get an image that has 2 colors, perfectly light and perfectly dark, and we want it to like kind of represent the original. That is the plan. So I think the first thing I want to do is I want to smooth out the histogram a little bit. Specifically, if our region is kind of small, this is kind of hard to interpret, right? It's very noisy and almost like possibly flat, like, right? You could imagine like drawing a line here. So if we were to like smooth this out a little bit by averaging the bins, I think that we'll get something that might be a little bit more defined. So I did want to try that. At the very least, let's try it and see what happens. So since the other day, this has all been merged into like the actual QR code decoder repo. So it's a little bit different than we saw the other day, but it's pretty close. Somewhere in here, we have this like server, and our web UI will request to get a histogram, and we will handle that somewhere. Handle histogram. This is generated in our like application state. He calls, hey, let me get this histogram, and let's just try for now. We'll like maybe add a like smoothing radius, and let's kind of set this to some U size. Let's say that we are going to smooth by going from let's see. So we're looping over every pixel in our image. And we are then saying, hey, we counted this many pixels at this brightness. So that's here. And then we want to smooth it once we have all of the answers. So we can say for 0 to ret len, we can say, then we're going to go over some smoothing radius. We're going to say like smoothing start is going to be I minus smoothing radius over 2. But this could be at like 0 or at the end. So we need to like do a saturating subtraction, which I think Zig has built in with this like minus pipe. It's either pipe minus or minus pipe. Zig saturating add. Operators. There we go. It's the pipe. Jeez, look at that. Minus pipe equals. So the pipe goes after the minus. The smoothing end will be the minimum of the length of the histogram, or I plus smoothing radius. And then we can just go for smoothing start, smoothing end. We'll call this like J, I guess, doesn't really matter. And we'll compute some average. And we'll say what? Average plus equals ret b. I guess we'll call this unsmoothed actually, because we don't want to adjust the unsmooth version as we're iterating. And then at the end here, we will just say ret p, ret I. This is going to be I here. Is equal to average. We actually don't even have to divide here because I think that everything will just scale relative to each other and it's fine, probably. Unsmooth len, and then we do the same thing here where this is ret, and we actually don't even have to stash the average here. We could just say that ret I plus equals unsmooth j. Yeah. And then we have to set this smoothing radius. So let's just, we might as well just like immediately parameterize this because I know that I'm going to want to check how it looks at different sizes or at different smoothing amounts. So we might as well just hook that up now. So in the server, when we handle the histogram, we're going to look at our query parameters for this request. I think I called .in here. Not late today. That's cool. Hooray, we made it. I kind of assumed that if you were late every day, like, I assumed that you'd be late every single time because your time zone would just line up shittily with the stream because I stream at the same time every day. But pretty cool that you managed to make it. Okay. So here we're going to have some query parameter that we get in our request. And we're going to say if we see a parameter that is equal to the word like radius, smoothing radius, I guess we'll call it. And we see that with the given key. Then we have to parse the smoothing radius as an int. So here we'll start by, maybe we'll set some default. It's 23:08. What time zone is that? Is that like Western Europe? Time in UK. A little bit east of England. Spain. Nice. Cool. Okay, so we're going to look for a smoothing radius, and if we get a smoothing radius parameter, we have to parse it as an int. So we'll say var smoothing radius, and he's going to be usize, and maybe we'll just default him to no smoothing. 0. I think that works with the way that we set up the histogram. -0 to +0 just does nothing. I think that's fine. No. We need to do... I'm actually not sure about this. We need to make sure that in app, whatever we set here, has to be able to handle no smoothing. So here we're iterating from I minus radius over 2 to plus radius over 2 it's supposed to be. And I guess what we should do is handle odd numbers in some way. So what we want this to do is we want this to end up going to 0 to 1. Right, so I minus 0 to I plus 1 will end up just copying I, which is what we want. So this is like smoothing radius over 2 subtracted, and then add in, this has to be plus smoothing radius %2, I think. And then I think a smoothing radius of 1 will do what we want. Yeah, let's try that. Maybe, I don't fucking know. So here we have to parse the string and turn it into an int. So it's stood format parse int as a usize, and it's param.val maybe, and in base 10. And then here we can call our histogram function with the smoothing radius. Nice. And then everything else just happens. We need to make sure that we can get query parameters here. So we'll say, hey, if somebody gives us some extra trailing shit on this histogram, don't worry about it. Try to parse this query params. We're fine with that. And maybe that just runs now? Not quite. We'll just throw 0 smoothing in there on initialization, 280. It's almost like we want to stash the smoothing radius because we're going to be calling this here. Like when we pick a new region of interest, we reset the cluster finder and we like pull in a histogram for that. But maybe we can just use 1 here, and when we change we do actually need to like stash this shit. Somebody's gonna call, hey, I want to set the smoothing radius. Hist smoothing radius. It's gonna be usize. Yes, this makes more sense, I think. Then we're going to set his hist smoothing radius to 1 or something. Then we're gonna have histogram isn't gonna take this in anymore. He's going to just use whatever he has stashed. And we're gonna have a set smoothing radius. It's camel case in this language. Like this, and he's going to take in maybe the radius. Yeah. And then we just say self hist smoothing radius equals radius. Okay. Okay. Then here we can use self hist smoothing radius. And I think we're chilling. Okay, so on the server side, we need to now add this set hist smoothing. We'll call it here. Like this. So set hist smoothing so we can match it. This guy doesn't need beginning match type anymore. And then here we can say we have a new thing that we can do, and it's set hist smoothing. And then somebody is going to try to switch on all these guys, and we have to set them up. So set hist smoothing, handle set hist smoothing, and that's going to look very similar to what we had previously in handle histogram. And we'll just kind of like split this stuff out. So we'll take the query parameter matching in here, slap it down here. This guy then just says set his smoothing radius to the smoothing radius. He now doesn't have like a default parameter. If somebody's calling this, they better fucking actually send it to us. So we'll say that it starts as null, and then we assign it. And if it's still null down here, we'll call this maybe the optional version. And then we'll say const smoothing radius is the optional version, but if it's not initialized, then we will return an error. So we'll maybe log here. We'll say smoothing radius not provided. And then we'll return an error. Return error invalid argument, maybe. Okay. And then at the end of this, we also have to say respond empty request, because they're going to be waiting for us to say we did it. So you have to say we did it. We succeeded. Thank you for giving us for asking us to do something for you. App.zig 122. There's a argument here that we don't need anymore. And server 189, we forgot to write try here. Otherwise it looks like we're chilling. Okay, so this is working, and now I guess, let's say, we'll spin up a new shell so that we can run the server in the background while we edit the JavaScript live. We have to give him a sec. He's thinking. He's got a hard life. Zig, build, and run, and we set the www root to source res, here. Okay. So let's add a little slider here. So maybe we'll do it here, and we'll say input type equals range, and min is equal to like 1, and max is equal to like, I don't know, 100. And I think it's like this, and then we can say label for equals what, smoothing range? Yep. Smoothing range. Yep. This is ID is equal to smoothing range. Okay. Refresh. So we have this smoothing range that I can slide around. I guess we need to set the initial value. So value equals 1. There we go. And now, hopefully when I slide this around, if I go into index.js, I can attach something to this button. So I can say smoothing radius on change. We can say update smoothing radius. Boom. And then we'll have some async function. Update smoothing radius. And he is going to do something that's very similar to this. He's going to set, what do we call it? I don't remember. It was set hist smoothing. And what is the parameter? Smoothing radius? Yeah. Smoothing radius is equal to, and then we just have to grab the value. So the value is going to be from some element, smoothing range, and then we just shove that shit in here. We don't need an image refresh here. We do need a histogram refresh. Okay. It's doing nothing. It's doing nothing. Why not? Why not? Get element ID is null. Which one? This one. Why? Why? Oh, it's because it's smoothing range. Okay, let's try again. Refresh. And are we chilling? Chilling. No, we're not chilling. Refresh. Oh, there we go. Oh, there we go. Hey, there. Nice. Okay. Yeah. So we start from here, and we can like kind of like increment it here. Oh, yeah, baby. So we can probably get like pretty wild with it, to be honest. God, that's so cool. Look at that. Okay. So on like small area like this, probably like around there is pretty good. And does that kind of like extend anywhere? Yeah, it feels pretty reasonable overall. We could probably do a little less. Maybe something like that. So like I don't know what's going on. Oh, well, I was gonna say I don't know what's going on here, but I guess it's that the region is just too small. So let's assume that when we're doing our like actual thing, we'll be looking at maybe a region that's like around this size feels good to me. Like maybe like almost a quarter of the image might be what we're looking at. Maybe a little smaller, maybe something like this. We need like enough data that it's like reasonable, but not so much data that we're just looking at the whole image, because we want to preserve some sort of like local data, maybe. Maybe global's fine, to be honest. Right? Maybe we look at the whole thing and we identify that there are like some dark peaks and some light peaks, but we need to correlate them together. Yeah, maybe what we do is we kind of like maybe we walk over the whole image, selecting some regions, and if like there will be some trends, right? In this section of the image, we're always going to be seeing like the cluster here and the cluster here. And on this side, we're always going to be seeing like this dark cluster and this light cluster. And then maybe over time, we can kind of correlate those with the full image as like which clusters can we expect to be dark and light or something. Maybe. This probably, like, the way it is right now probably works a lot better now. This, like, just start with the next biggest thing. Can you test regions against an expected pattern? I guess the problem is that, like, I don't know what the expected pattern is. I'm expecting to have light and dark, but that's kind of about all I know. Actual shape. Not the histogram. Like I'm expecting a finder, like if I'm looking for the finders, maybe I'm expecting this shape here. And maybe there's some image transformation I can do to get there. Maybe. I feel like I feel like before we start, we just need to get it into like black and white. Denoised. That's how I'm feeling right now, but it could be that that's the wrong approach. But we'll see. We'll see. Well, maybe we'll just keep going and see what happens. Okay. So we kind of did this, and let's say that we are at 2350, and let's try to like look at the binning algorithm. So right now what he's just doing is he just sorts the histogram, and he says which point is tallest, and I'm gonna look at that one. And he's like, which point's the next tallest? I'm gonna look at that one. And if they start to be like close to one of the ones that is already marked into a cluster, he kind of like merges himself with that. I think what I want to do is I want to like kind of start by just like walking down the hill to some amount, right? If we just like look, we start with the center guy and we go like bloop, right, until we hit some threshold, and then we move on. Maybe that will give me something a little bit more sane. So let's maybe like, this is like kind of like the idealized version of it. And maybe we say like, while we walk to the left and we see a large decrease, or not even a large decrease. We see a decrease. Maybe we just keep walking until we see an increase? Maybe? Maybe. So then we would like kind of like take this section as one thing, and then this section is another thing. This is another thing. Yeah, okay. Let's try that. Let's try that. So, found this Twitch stream from YouTube algorithm, by the way. Hello. That's good to know, because that is kind of part of the strategy. Was hoping that by posting to YouTube, people discover. The discovery is a little bit stronger there than on Twitch, maybe. Saw Zig, that was neat. I also think it's neat, which is why I'm doing it. So glad that extends to others as well. Okay, so we grab like the biggest bucket, and we say, hey, does it belong to any cluster? And if it doesn't, then we add to that cluster. And maybe what we should do now is look at that cluster ID, and we just kind of want to say, maybe we do this. So we say, hey, I'm going to add this item to the cluster, and maybe instead of adding a single item, we'll add a range. So here we'll say min, and here we'll say max. And just when we add a cluster, we're going to like walk left until we see an increase. Is that VimWiki? I've heard that a couple times. I don't know what VimWiki is. This is just a markdown file. And then I type into it. I don't think I need anything more advanced than that. But maybe one day I'll discover that I do. Okay. So maybe we'll say, while... Okay. We'll say min is equal to the biggest bucket. And while our histogram at some value, maybe we'll just say while true for now. We're gonna say like if any, we'll say like, I'm trying to like figure out like some sort of like extra smoothing that we might need. Maybe we don't. Maybe we don't need it. Maybe we just say if histogram self histogram at min minus 1 is less than the histogram at min. Min equals min minus 1. If min equals 0, we have to break. And then else here we break. And then we do the same thing for max, but in the other direction. So we say if max is equal to histogram len, then here we say plus 1 is less than still plus 1. And then we add the cluster min max. And then let's just double check this logic here. So we say, hey, if our thing is less than cluster min and within some epsilon of it, we add it. This is maybe a little sketchy. But for now, let's just do this. If it's, we'll get rid of this like epsilon shit. And we'll just say if the bucket is bigger than cluster min, maybe greater than or equal to, and the biggest cluster is less than or equal to cluster max, we don't have to, we've already covered this guy, so we won't worry about it. Let's just see what happens if we do that. It doesn't compile, obviously. Why would I expect anything different? Here I have to say URU size so that, oh no. Oh, it's because I wrote const here. I wrote const when I am mutating this guy, and then this should be max and max here as well. All right, refresh, boom. So next. Okay, what if I smooth more now? Why is it only going to the left? Max equals max plus 1. Oh, it's because I wrote min here. Oopsies. Oopsie daisies. Okay, refresh. So here, oh, core dump. Nice. What did I core dump on? Oops, this is if max plus 1 is equal to histogram.length. Oopsies, 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 oopsies. All right, let's try that again. Okay. Let's smooth them a little more, and then boom. No, oh. That didn't do what I thought it would do. Something here is so fucking wrong. Oh my god. I keep writing, dude, this is why functions are good. Like, limiting scope so you don't fuck up and use the wrong variable. Pretty nice. Interesting. So this, it's not working like I thought it would, to be honest. Like, I'm pretty sure that if I look here, oh, there is a very slight increase. Okay, so we also want to like handle some amount of jitter in the signal. Okay, so it's like if let's think. How do we determine how much jitter to handle here? Right, because there's like some amount of very slight uptick happening here that's resulting in like the algorithm stopping. So we need to say like if we need to like count, I guess we'll do like percentage. If it goes up by less than n%, then we'll allow it. We will eat that guy as well. So maybe we'll say, we can call this maybe epsilon. Or we'll call it jitter. I don't know. I don't really have a good word for it. But like, how much can we increase and still consume? But that's not really what I want either, to be honest. Because what if you have like a slow hill climb, right? If you have a histogram that looks like, you know, this, you're going to be doing something like, you know, if you start here, you're going to go down, 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 down. But if each one of these increases is less than 10%, then you're going to be like, oh no, right? You're going to like you're going to keep going all the way and consume everything, which isn't what we want. We almost want like if the trend line is positive. Right? You almost want to take like the derivative. Interesting. Interesting. Perhaps take min and max into account. Oh, yeah, I kind of like that. So, like, you kind of, like, keep walking and you say, if, like, the slope of max to min is, like, lower, like, if we have a steeper slope, maybe? I mean, you could just smooth more as well, right? If you smooth enough. Oh, even like infinite smoothing, you still have enough jitter that it's a problem. I guess. I feel like this is obvious and I'm struggling. Are we searching for peaks? I'm more searching for like distant, like I'm more trying to like bisect, I guess. Like I'm trying to like consume like this whole segment here. Right? So we start here, like this is like pretty good. This is what I kind of wanted, is like he goes here and he goes yum 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 yum, and then he hits here and he goes, okay, I'll stop. Maybe it's okay. Let's just keep going and see what happens. Maybe we can just handle this by merging clusters a little bit more effectively. Let's try that. Let's try that. So we'll say, first of all, I want to fix this next spam. So maybe I'll put a little bit of like a while true in here. And instead of returning at this point, we'll hit continue. Then we break at the end. And here we do var biggest bucket equals undefined. Then we set this guy here, and then we have him down here. And then we just have to do some sort of like cluster merging. But I don't know what that looks like yet. Let's just start here and see what happens. Start here, see what happens. Okay. That's obviously not doing what I want it to. It's like eating itself, which is bad. So what's happening here? This should be return. No, this should be continue. So if our bucket is within some cluster, we don't use it. Why am I like consuming another bucket here? I guess it's because probably in this like hill climbing stuff. No, I'm not like. Okay, that's fine. What's happening here? Here we must just not be hitting this case. When the slope changes direction, it's a split. Yeah, I agree. I like understand that, but I would just think that like I don't know how to that's effectively what I'm doing now, right? It's just that the slope, I'm only considering the slope over like a distance of 1, which maybe is wrong. Right, you almost want like average, you want to like smooth out the line, if that makes sense. Which might just be, I guess you could just do more smoothing iterations here. And that would do the same thing. So you could say like, I want to smooth over 3 elements, but just do it like 2 times or something. And maybe that results in something that has like a more consistent slope. Maybe. I have to think about it. Because there's this thing, kernel density estimation, which kind of does exactly what we want here, I think. Where instead of giving like bins like this, it creates like a smooth function. And I'm pretty sure that all they do is they run a kernel over, like they're essentially doing histogram smoothing, where they say, hey, we have a kernel, and the kernel, where do they define these things? Here. So you'll have like some kernel that says like multiply things within the range -1 to 1 of my guy by like 1. This like we're essentially doing by just doing like a moving average. We're essentially doing this box version, but they have like other distributions where you say like weight the stuff that's closer to me a little bit stronger. But they're essentially saying like, hey, look at the points within some distance of me and average them in some way. Which is effectively what we're doing by doing a sliding window over the histogram. Then they do, I think they have, what do they do? They just sum the thing and divide by h, which is smoothing parameter called bandwidth. I see. So that's the part we're not doing, but it's effectively the same. And then maybe we get some sort of like nice differentiable thing out of it. But for now, I want to fix at the very least the edge casing here. So here we need to say I guess we just do this. The same if condition here. We just do it on each, like when on the border. So we say pub function is in cluster, and we take a point. So we'll say function any cluster contains, and we're just going to say point is a usize, and we will return a bool. And then we just do this loop here. Yeah. Boom. Okay, so this just becomes now if self clusters, any cluster contains our biggest bucket, we continue. And then down here, we say if min equals 0 or any cluster contains min saturating sub 1. And then here we say or self clusters, any cluster contains max plus 1. I guess we don't need to saturating sub here because we've already checked this equals down here. So hopefully that fixes the fact that they like start overlapping with each other. Oops, doesn't compile because this is return true and this is return false here. Oopsies. Okay. Boom, 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 boom. Okay, at the very least now they're not overlapping with each other, but we still have the problem where they're not consuming enough. I thought you were programming in Go. Nah, a little bit of Zig. A little bit of Zig. A little bit of Zig, a little bit of HTML, a little bit of JavaScript. All right, I'm gonna try adding this like jitter parameter and just see what happens. So if this is less than min times jitter, I think we just do this in both spots. Oopsies, and this should be minus. Let's just see what that does. And then I guess we have to cast this to, oh god. Self histogram min minus 1. Let's do a little bit of nice naming here. Potential idx is equal to min minus 1. We say histogram potential idx like this, and we cast this to a float. Multiply it by the jitter. So we'll say potential val with jitter is a float 32. And this is actually plus minus this times self histogram min. Okay, so if potential val with jitter is this, and then we'll copy paste this down here and just adjust. So this is max plus 1. And this is max. Okay. And this is potential val with jitter. Okay. So now we should allow at least some movement. Maybe too much, maybe too little. We still fucked up because, oh my god. Const current val f32 is equal to this float from in. I appreciate this, but it's annoying. Which is kind of its point, right? They're trying to make it so that it's a struggle to do this casting stuff so that you're aware of it. But holy fuck. Holy fuck. So it's like this, and maybe this one as well. These guys get turned to floats. Is there anything else that we can do to clean this up a little bit? We can say const potential val f32 is equal to this, and then that cleans it up a little bit, because now we can just say potential val f32 minus this. Yeah, I like that better. All right, I think that's right. Might not be, but it might be. Very well might be. So let's say now we hit next, 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 next. Still no, huh? Next. Oh, that did something. Next. Next. Okay, so now the jitter is just clearly too high. So let's maybe drop it down a little bit. That or I wrote a bug. We never know. Okay. That feels getting close. We're getting close. What are we working on? So there's top right corner kind of summarizes a little bit, but what we're trying to do is we're basically trying to figure out how to turn this like QR code into a clean black and white image so that we can process it to like find the finders and stuff. And so right now we're looking at this like histogram. We're trying to like identify kind of like which segments are dark and which segments are light given a certain area of the histogram. Or sorry, given a region of the image. So we like generate a histogram, then we take like the tallest part and then we try to like consume the people around it. That one worked pretty well. That one worked pretty well. And then the idea is that like hopefully we can look at this and say, well, this stuff over here is going to be the lights. This stuff over here is going to be the darks. I have to find some way to like, maybe we iteratively take each chunk from each side, kind of like fold them in. Because like here, I'm not actually even sure what this middle section is. Okay, let's try this guy over here, and we'll smooth this a little bit. Okay, I also wanted to change our histogram smoothing a little bit. I don't like the idea of it always consuming farther away, if that makes sense. Like, we have smoothing radius, but I also want to do like smoothing iterations. And so I just want to say that like, so how do this? We will loop 4 0 smoothing iterations. We're going to do something. And I guess it's going to be like, we copy the unsmooth data into ret here. No. We have the output, and just at the end of every iteration, we copy, yes, mem copy, we want to take the current return value and put it into unsmoothed. So the idea is that on each iteration, unsmoothed gets updated, and then we update ret on the next iteration, boom. Is Zig compiled to WASM for browser interactions? That is an approach. I have not looked at that right now. Right now what's happening is we're just doing everything on the back end and exposing some like JavaScript web, like we're just exposing some JSON endpoints to get the data that we need to get. Okay, so image histogram. Here we also want to save hist smoothing iterations. Set, then when we set this guy, First we'll say hist smoothing iterations we'll set to 0, 1, 0. No smoothing by default. That seems reasonable. And whenever we set this guy, we'll say set smoothing params. Params with the num iterations. And then we can say self hist smoothing iterations equals num iterations. Boom. Right. I think that that's all of the places that we needed to put this. So now in the server, when we get a set histogram smoothing, we can just say smoothing iterations, and we will also make this something that's checked. So we'll say, hey, we'll start it as null, and if we don't find it, then we've got a problem. You know, smoothing iterations not provided, and then here we say smoothing iterations, pass that guy in, and then we just do a little else if we see smoothing iterations, we set the smoothing iterations opt. Boom. Boom, boom, boom. All right. Might be good enough. Probably won't compile. It never compiles. But if it did, then it might work. Right, so this isn't radius anymore. This is params. And unsmoothed is not an indexable pointer. So at app 264, I just have to put a little ampersand on this guy and this guy to say, hey, could you coerce those into slices for me, please? And maybe we're chilling? Looks like we're chilling. So why am I not getting the histogram? Smoothing iterations not provided. Good thing that we put that error log. So I guess we'll do the same thing here where we say, hey, can we look at iterations? And maybe there's like some max value of like 5. Maybe we just make the input type here number. And then just don't set min and max. And then in our index JavaScript, when we set the smoothing params, we just have to add in plus, like it goes plus on this side, and smoothing iterations is equal to the number of smoothing iterations, which comes from this guy. Boom. Okay, refresh. All right, so error handling request. What's going on? Set ROI. That's fine. Histogram. We're getting the histogram. But something's wrong. Something's wrong for sure. Okay, let's go back to app and look at our set smoothing. Okay. I'm assigning him here. And then I'm using him in the image histogram call. And here, we are just iterating for 0 to smoothing iterations. Mem copy is source to dest. Yep. Here we assign dest. I'm just not seeing it. I'm not seeing it. Okay. Let's just do the stupid thing and just go back to where we were before. Right? Just ignore this completely. Like, surely this shouldn't be broken. Right, this is fine. That's working as expected. So how come doing anything here is not working the way we expect? Oh, Let's make sure that when the smoothing iterations change, that also updates the histogram. And that's doing nothing. Cool. Can we maybe look at what request is being set when this changes? We are calling smoothing iterations equals 3. Are we getting errors here? Boom, boom, boom. No. So nothing's complaining. What am I missing? Smoothing iterations comes from here. We would error out if it wasn't getting set. Let's break out GDB, I guess. This is at binarizing debug, break at this line, run with image path, fuck. GDB args, break at this line, run. Okay, boom. Let's look at our smoothing iterations. 7, okay. Then what the fuck is the problem? We zigging? We sure are. We are zigging and zagging, that's for sure. Okay, so this guy, we are 100% using him here. And is it possible that, like, it's just not doing anything? Like, is that possible? I don't see how it would not be doing anything. So clearly when I get to 0, it's clearly not doing the 0. Like, that's clearly having an effect. Oh. It is doing something and I'm just an idiot. Okay. So with one iteration, right, like we can just do this. There we go. There we go. Okay. Now, when I hit next, nothing's fucking happening. Super cool. There, that did something. Here we're back at that problem where our jitter is too high and it's climbing up the hill when it shouldn't. Which is annoying. I would prefer to not have like a tunable parameter here, to be honest. Let's go back to 0 jitter. And see if with the extra smoothing, we can get away without it. So maybe we don't need it if we just smooth more, you know? Okay. Nothing is happening. Why? Why is nothing happening? We are getting clusters. We have clusters. But they're just not doing anything. Minus jitter times this. I guess the fact that our clusters, we need to make sure that the max value is inclusive in our clustering thing. So we'll double check at the index JavaScript. Something's happening on the far right. Oh, there is something happening on the far right. Good eye. Which is, oh, there we go. That looks kind of right. Oh, yeah. Wait, that's doing exactly what I want. So with no jitter, it's working kind of correctly. So now let's go back to maybe increasing the smoothing range to try to get, well, what are these peaks? That's what I want to know, is like, okay, if we did something like this, like that's like almost perfect, right? Boom, boom, boom. Right? That's super fucking clean. Super clean. This Otsu's method? Who the fuck is Otsu? Otsu's method. Oh, this is pretty funny. Wow, this looks a lot like what we're trying to do, huh? He's doing some sort of moving average and looking at variance. This is not Otsu's method, but this is an interesting thing to know about for sure. So he is. I don't even know what that's. That's pretty nice though. Whatever the fuck that is. So what is he doing? Gross. Oh, that's a lot of letters. Weights of the probabilities of two classes being thresholded. Optimal thresholding for contrasting images. Yeah, this is just better than what I'm doing. But I'm going to keep doing what I'm doing because I haven't read this and I'm not going to be able to parse this effectively immediately right now. So we're just going to keep going here. But I think I'm kind of happy with what just happened here. When we reset, something just crashed. Fuck. Integer overflow. Oh, because okay. Hold on. We integer overflowed for sure. At our application. Here, let's just say ret I divide equal by smoothing and minus smoothing start. Boom, boom. And then hopefully we won't overflow like we did there. Okay. So there's something wrong going on with like something's not resetting. Like if I refresh this, like the clustering algorithm should be resetting here and it's not. So let's fix that. So maybe that's on set here. We need to clear the cluster finder and reinitialize him with this. Yeah. Like this. Boom. And output image comes from ourself here. All right. Try that again. This guy is considered non-failable, so now he can fail. So we go back to server and we call set histogram smoothing parameters. We write try. Boom. And now hopefully, like visualization state is like consistent. We also have to set reasonable starting parameters because whatever is getting set off rip is just wrong. This should be 1 by default. There we go. There we go. So now, refresh. There we go. There we go. So probably, just like kind of like eyeballing it, it feels like around here is a good smoothing range and like maybe like a lot of iterations is good here. And then let's just add a very, very small amount of jitter allowance. Okay, next. Yeah. That feels good. That feels good for sure. Boom, boom, boom. Boom, 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 boom. Yeah. Look at that. Look at that. It's clean. It's fucking clean. Boom, boom. Boom, 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 boom. Oh, yeah. I'll take it. I'll take it for sure. Okay. Cool. So now what we have to do is we have to figure out how the fuck to, like, bisect these guys. But I think it's just, like, probably we start at the leftmost bin and we set it to dark. And we start at the rightmost bin and we set that to light. And if there's an odd number, like maybe we just prefer whichever one has less of the pixels, right? Let's like assume that we want about 50-50. And so if we are unsure, then we just go beep boop, I will be in whatever category has less. Yeah, that seems reasonable to me. Seems reasonable to me. Oh, maybe we need more colors a little bit, but that's fine. Yeah, I'll take it. Boom, 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 boom. Jitter is allowing a little too much. Maybe we even need even less jitter. I don't like that I'm seeing red climb up a little here. Yeah, there we go. There we go. Good enough for me. Good enough for me. All right. I'm just going to put a note here. This is sketch and can allow for climbing an adjacent hill that we shouldn't. Probably something that approximates slope and looks for bottoming out is better, but we were not smart enough to do that without thinking very hard. There we go. We'll say we could do better, but we're just not going to right now. Okay, there we go. I think this epsilon parameter isn't used. Yeah, it's not, so it's fine. And okay. Okay, so I think the next step is to take our clusters and sort them and then bin them. So I guess for now, since this is all like in our like debug visualizer mode, maybe what we do is we add a URI for a binarized image. And we do this little trick, by the way. This is kind of funny. I don't know if this is how you're supposed to do it, but when I update the image, I need to like force the browser to re-request it. So in our like index.js, we just like append the timestamp to our request as a query parameter and are just like, well, it's a new picture because you asked for it now. Every time you ask, it's a new picture. So that's why we say our match type is like begin instead of an exact URL match. This guy, we need to say that our purpose is binarized image. And let's see now. What are we going to do here? We're going to say, hey, if handle binarized image. If we get a binarized image request, we're going to try to handle that binarized image request. And that's going to look very similar to handling an output image request, which is our blurred thing. Handle binarized image. All right. And so we are going to have to say, hey, application, could you give us a binarized image? Okay. Yep. And then in our app, we're just going to have a binarized image. And we're going to have to make that thing somehow. So that's going to be like extract binarized image from something. Input image and the cluster finder, maybe? Maybe. Can you speak to using Zig at all? I got off the Rust bus recently and I'm looking for something cleaner. I'm thinking Zig, but curious to your experience on it. It's pretty fun. I would say it fills this niche that I think needs to be filled. That's like, Rust is kind of like C++ for C++ people, right? Like C++ is shit, right? I don't think anybody really likes it. Maybe I'm wrong, but I feel like It pisses me off. But like the things that like make C that people like in C++ that you see people write about, like modern C++, it's like if you took modern C++ to the extreme, right? And then just didn't make like crazy design decisions in the middle. I feel like Zig is like if you took the same like C++ to Rust is like C to Zig is how it feels, where you've kind of you've kept like the simplicity, but you've tacked on a lot of stuff that like is nice. I guess it feels like what C++ could have been in some ways, right? You have like these generics that you can generate, but they don't come with like this bullshit template system, and it feels good, hand wavy, right? But I would say that I would not use it in production. That seems scary, right? Like, there are some languages that aren't fucking going anywhere, right? Like, C will be around forever. C++ will be around forever. Rust, it seems like, has enough momentum that it's going to be around for a long time. I don't think we have to worry about it going away. But Zig is like, you're kind of relying on this one guy to like keep driving it in the direction that he's been driving it, and it's like that being owned by like one guy is like really nice in that like there's like clear direction and clear consistency, and it's like you don't have this like design by committee where you get like shitty stuff out of it. But what happens if he decides he gets bored of it, and like if we just stopped making new Zig versions, like if one guy on GCC stops working, it's not like GCC is going away. But like, you'd have to worry about that. So I don't know if I would use Zig in production, but it does feel like if it gained more stability and like more longevity, it definitely feels like I would use it where I would have used C++. Sorry, it's kind of rambly, but that's how I feel. If that's helpful. Extract binarized image. We take our input image, which is going to be something, a image. We're going to have our clusters. So I guess we don't pass in the cluster finder, we pass in the clusters. And this is going to return an image. And I guess we need some sort of ROI from the input. Maybe we're going to use the, actually the blurred image. Blurred. Yeah. We'll just binarize the image. Yeah. Modern C++ is so alien to me now. I feel like I was like comfortable in like C++. Actually, yeah, C++ 11 and 14 were like fine. Right, I liked like auto was kind of nice. Range-based for loops kind of nice, or yeah, is that what they call them? Range-based fors were kind of nice. Like the like increase of like shared pointer, unique pointer, move semantics. They're all kind of nice. Writing any class where you try to use move semantics is fucked. Right, like writing a class is just hard in C++ now, but the move semantics are kind of maybe arguably worth it. Maybe. Right, being able to express like unique pointer is like something that you couldn't do before, which is kind of nice. Then I haven't really worked at like C++ 20. C++ 17 just felt like they went ham on constexpr, which I liked. But yeah, I don't know. I noticed that recently that C++ modules still nobody uses. Like, it's not even implemented, which is really funny. It like became part of the spec, like 4 years ago? And just like nobody's even finished it yet, which is really funny. Wonder if Zig could fulfill the C promise Go tried to make, but instead Go is more like Python replacement for cloud and not systems language. I was wondering about that. I was Googling. Okay. This is going to sound so fucking stupid. Really fucking stupid. But why, when do you use Go or Java? I'm like not sure. Really, like, because I get like if you're trying to write something like high performance, you drop to like C, C++, Zig, Rust. Like all of those guys kind of fit that, right? If you're trying to like bang out something, you work in Python. And it's like, what is the middle ground there? Like, I guess you just want like something that's like a little bit faster than Python, but like not enough faster. Like you don't care enough that you want to go all the way. Like I just don't really see where like Go and Java fit. You know? So when you say like it seems like the C promise Go tried to make, it's like I get it. You're saying it's a lot faster. So you're like, yeah, I guess Python's pretty fucking slow. But then you end up using it to stitch together C modules. So you're saying like, and cloud software kind of makes sense because I was also thinking like, if you want to use any system integration, then like I would imagine that C, C++ is like everything speaks C, so that's like feels like a better fit. You want fast, but you don't want to manage memory. Okay, sure. So I just feel like with maybe I'm just like too deep in the fucking sauce, but I feel like managing memory isn't that bad with RAI, right? Like if you just have scopes and you write like I guess C++ is shit. I guess the difference is you're just saying okay, sure. I was gonna say like with like automatic deallocation on destruction, it's like who fucking cares? Like that's just as good as garbage collection and more flexible. But then I guess if you were like your options were C++ or Java, I can totally see why you would skip C++. Like fuck that shit. I think it's that most devs just haven't managed memory and are generally scared of it. I could see that. But like, isn't working with a garbage collector just as frustrating? Like when you're like, oops, I have a circular reference and I have a leak. Like you just have like kind of like more roundabout leaks, don't you? Maybe that's what my guess. But I guess like I'm just talking my ass because I don't really use garbage collector language that often. Good modern Go is not as slow as you'd think about to management memory. Orders magnitude faster than Python, a little slower than C++ Rust. Okay. I can see that. So you're like, we want to go faster, but we also don't want to like waste all of our time debugging stupid shit. I can see that. I could see it. Yeah, everyone's kind of saying that it's not as far from C as I would have guessed. Right? Like it's not like it's like C halfway to put if you have like C here and Python here, it's not like Java's in the middle. It's like C, Java, Python. In which case, sure. I can see it. Okay, and I want to extract an image from this image, and I have my clusters. So first, we kind of have to like categorize our values. So we'll just say that dark max is 0, and bright min is 255. These are U8s. And we just walk our clusters until we run out. So we'll say like our cluster or dark cluster index is 0, and the light cluster index is clusters len. Items len, like this. Are you enjoying Zig? Yeah, for sure. I think it's fun. It feels like Rust kind of like I like having written Rust, but it is a little like you have to write it their way. And so like having the freedom to fuck up is kind of nice. You know? These are U sizes. But writing this again, it feel like writing. I feel like maybe C is not so bad anymore either. You know, it like once you learn the strategies from being forced to write Rust, then like those strategies can apply anywhere, and it's like maybe it's fine. You know. Okay, so I had to sort my clusters, I guess, huh? Maybe we even just take in cluster range here. And here we say std sort PDQ our clusters, which are elements of cluster range. Context is probably nothing. I probably don't give a fuck. And then the sorting function is going to be like what? I don't know. Struct. We have some function f who takes in something. Sort function. So what does this guy take in? Function that takes in this thing. Well, bum 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 bum. And T context here is void. Left hand side is cluster range, and right hand side is cluster range. Boom. And we're just gonna say LHS min is less than RHS.min. Sure, that's fine. Good enough for me. And we'll just say that while dark cluster IDX is less than light cluster IDX, we say that the dark max is clusters. Hold on. It's clusters max. Clusters dark IDX. Dark cluster IDX max. And then the bright min is clusters dark light cluster IDX dot min. Defer dark cluster IDX plus equals 1 and light cluster IDX minus equals 1. Here we have to be a little bit careful. So here we know that they're not equal, so we're okay doing this. And then if they are equal at this point, we just pick one. We just pick one. Anyone know how to switch between .h and .c files in NeoVim? Go to definition. I use Clang D has a switch header source thing in it. I have it bound to H maybe? Yeah. Clang D switch header. Switch source header. That's what I do. But there's also something called like a.vam if I remember correctly. But that I haven't done it. I haven't been deep in C++ for a while, so don't take my word for it. Okay, so if these are the same, then I have to assign it to 1. So we just have to say, I guess here we're gonna count how many items are in each of the 2 bins. So we'll look at our histogram. This is having U sizes, and I guess this is by const as well. And we'll just say for num dark pixels is going to be 0, and num light pixels is going to be 0. And we'll just say for 0 to the dark max, we can say num dark pixels plus equals histogram I, right? We can do the same thing for light min to histogram len. The num light pixels, it's like this. And we'll just assign it to whichever one makes sense. So we'll say if num dark pixels is less than num light pixels, dark max is now going to be the cluster at dark cluster IDX max. Otherwise, we assign the minimum light value. Yeah. Sure. That might work. This is ripe for bugs right now, but we'll see. We'll see. Maybe what we should do here actually is visualize the thresholded histogram. Yeah, so let's do that. We'll say function extract light dark threshold, and we'll pass in this stuff. I don't think we actually need the image at this point. And we'll just return a U size or U8, which is a pixel value. Yes, a brightness value. And so really here, we actually don't need to be tracking the bright min ever, because the dark max should end up equaling the brightness min later. Yeah, so I think we just take out that stuff. That's cool. And then all of this goes here. Okay. And now we need to actually call this somewhere. So we'll say dark light threshold is extract light dark threshold from the histogram. And the clusters. Clusters. What the fuck? Clusters, clusters, items. All right. Which means that we need a dark light threshold. Who's going to start at 128 or something, who fucking cares? You guys complaining about cloning in Rust? I will say, okay, so Rust cloning and arcs and RCs and stuff, like shared pointers and that stuff. It's like, you would just do that in other languages, except they don't tell you that you're doing it. And so it's kind of nice to just kind of embrace it sometimes. Where you're just like, look, like, copying this string is fucking stupid, but in reality, copying a string never fucking matters, right? Like, how often does it actually cause a problem? How often does it cause a noticeable slowdown? It's like almost fucking never. And so, like, if just do it, you know, clone, 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 clone. Fuck it. Like, who cares? And you know, the language will like kind of guide you into not doing that, and you should listen when it's easy. But when it's not easy, like, fuck it. When I run ClangD source switch header, it just exits in 0 milliseconds. I'm using ClangD from a language server. I mean, if ClangD is set up right, that's always worked for me. But no promises. Your mileage may vary, etc., etc., etc. You know. Ugh, fucking shadowing. What an annoying thing. Okay. This guy he doesn't like light min, so this is also dark max here. Oh, maybe I did need to track light min. I lied. I do need it. Fuck. How do I get this back? This is the only part where it really matters, I think. Go back to here. Bright min goes here. Var bright min is equal to 55. Hopefully everything else is okay there. I shouldn't have deleted it. I've changed my mind. There. All right. Binarized image is missing. That's okay. We'll just delete that for now. Get this shit out of here. And coercion at 169. This needs to be a little ampersandy, probably. Yep. Expected this, found that. So put this guy, take the ampersand away. No field named binarized image. So we'll look at server, and this binarized image section will just return error unimplemented for now. And what we'll do is we will add a new API to get the like partition point. Dark light partition. Yes. And we'll say handle dark light partition. And this is going to look similar to like getting clusters, I guess. Handle dark light partition, and that it's going to return some JSON, but the JSON's just going to be like one number. I guess we just write the value. In which case it's not even really JSON. We just say like response writer write all, and we do a std format buff print. We need some buffer. Var buff is like 4 U8s or something. Because 255 is max value, so 3 is enough. Then we can write the value of self app dark light threshold into that buffer. So we'll call this DLTS for dark light threshold string. And then we just write DLTS here. All right. Here we need to use this buff. So I think we just write buff here. And const. Okay. If there's something to complain about in Rust, it's the lifetime's not borrowing. Borrowing gets easy if you use language, but lifetimes are a pain in the ass. Yeah, I've found that if you write a few, like after, like if you're doing more than a little bit of of lifetiming, give the fuck up. Like just, it's not worth it. It's not worth it. Just like in C++, if you're doing more than a little bit of templating, also stop. If you're like pulling out Symfony or ADL in C++, stop. Like, and it's the same thing in Rust. If you're pulling out too many lifetimes, stop. Like, just do the stupider thing. Okay, so now we probably need to say that there is some URL that we can call to get the, like, dark light threshold. And it's going to say dark light threshold. Is that what we called it? Get dark light partition is what we called it. Maybe I should use the same name everywhere. That would reduce confusion by a lot. So here we'll say partition here. All right. Let's see how fucked we are. Use ampersand to coerce to slice. So here I need to write var, and here write and, I think. DLTS has a possible error, so we write try there. Then we have 184 in app. And in here, what's it? Oh, okay. We fucked this up. So expected type cluster range found const cluster range. Oh, because we can't write these. So we need to say, hey, we want to sort these guys, and you have to let us. Dark max expected U8 found U size, so 182. We'll just do some int casts here. Because I'm pretty sure those can't be out of the range of 0 to 55. Num dark pixels. These guys have to be U sizes here. And function type function. Oh fuck, histogram. This is have an underscore everywhere here. Nice. Noise. Expected U8 found U size. So this is also an int cast. Are we done? No. Of course we're not done. Of course we're not done. This guy never returns. We have to here return dark max. Yeah. All right. Now let's see. Oopsies, we have to set the smoothing. And now if we call dark light threshold. Is that what? I already forgot. Server. Dark light threshold. Partition. Fuck. Dark light partition. So this is going to be 0. And actually, I think that we forgot to ever assign it. I think that we didn't ever actually set it, so. I guess when we set anything of interest, we need our exit condition from this cluster finder algorithm. So we need to say, here we return null if we've gone through all of our buckets. Otherwise, we're chilling. And then when we set ROI, we just run the cluster finder. Maybe we do it when we call, it doesn't fucking matter. It doesn't fucking matter. But every time we set this guy, we'll just say, while self cluster finder next, we do nothing. We don't give a fuck. And then dark light threshold is equal to extract dark light threshold given the histogram and the clusters or something. And is this the only place? No. We need to do this here as well. Which is wrong. This is all wrong. I'll clean this up later. Don't worry. Don't you dare worry. Don't you dare worry about it. This will get cleaned up. This is an ampersand here and here. And cluster finder next. Where is he complaining? Server, maybe? Yeah. There we go. Okay. So now when we go in here and we go like this, we crash. Super cool. So this is index out of bounds, extract dark light threshold at the light cluster index. So this is at app 193. So light cluster in the IDX is this -1. Oops. Oopsies. Okay. Integer overflow. So this has to be saturating sub. Okay. And then when we search this, okay, let's set our smoothing. Oh, there we go. Nice. Okay. And if we call this, we get a value of 90. So that's probably here, which I think is probably good. What about now? 27? That does not look good. What about over here? 202. It's almost like it's backwards. Maybe our sort... Maybe we should stood debug print the clusters here. Because it doesn't look like it's working the way I want it to. Does not look like it's doing what I want. Refresh, refresh. Okay. 0 to 1, 2 to 37, 38 to 77, 78 to 166. So that does look sorted. It also looks like there's way more clusters than I would expect. Oh, it's because these guys are... There's a bunch of really small ones. So it's almost like we want to discard clusters that are too small. So we want to do something like as we're walking the clusters, it's like here we're just going one by one. But we actually want to do something more like while clusters dark cluster idx dot max minus clusters, we'll say const dark cluster is dark cluster idx, and we'll say while true, we have this cluster, and if clusters max or dark cluster max minus dark cluster dot min is less than like 5. Dark cluster idx plus equals 1. And dark max is equal to this. No, we just keep incrementing it. This is a little sketchy. We actually don't want like the width of the cluster, we want like the number of elements in it. Yes. I like that. So let's do like num elms in cluster, and we'll take in the histogram and the cluster, and we'll return number of elements. And we'll just say var sum is equal to 0, and then we say for cluster min to cluster max, we have some index, and we just say sum plus equals the histogram at that value. And then down here we can say var const the total histogram size is equal to the num elements in cluster. I spelt this wrong. I want an uppercase C. And we'll just use the histogram as well as the cluster. We'll just say min is equal to 0 and max equal to 5. Which means that the num elements in cluster, this has to be +1. Or is there like inclusive ranges in this language? Sig inclusive range. I don't actually know. Range? Where is like the name of the dot syntax? Yeah, it doesn't look like it. Okay. We'll just +1 here. No biggie. No biggie. Okay, so we have our total histogram size. This, boom. And then we'll just say while something. While the cluster, while the number of elements in the cluster, yeah, is less than some threshold. So like total histogram size over 10 or something. 20, right? Like it doesn't have to be like crazy. It just has to be something. Yeah. And then I guess we do this for light as well. Which also has to be factored out, but shut up, you know? We'll deal with it later. Okay. Okay. Let's see what that does. This guy needs to be a usize. And refresh, draw an ROI, update the smoothing. And okay. Here is an example here where we should consume this green section, yellow, red, and orange should be turbined light, which means that we should consider here, 84. I don't know if this is 84, to be honest. This might be 84. So let's maybe draw a second histogram based off of with the splitting point. So here we'll say histogram 2. We're gonna get rid of this next button because it's not doing anything more. And histogram 2 is gonna be something. We'll figure this out. So in our, let's run over here, zig build and run this guy. And let's go look at our index.js, and we have render histogram. And I guess here we'll just we'll have a second context. And like, what's going on in here? We like figure out the bar width. This all stays the same. We clear the context, and then we render our bars here. And we set them to be blue. Here, what we'll do now is we'll set them to be like blue, and we'll set the colors to be like blue and yellow or something, depending on if they're black and white. So say if here we have to get the split point. So split point response is await fetch from dark light partition. What was it called? I already forgot. It's over here. Here, boom. So we get this guy, and then we split point const split point is equal to await response JSON. And then we say if I is greater than or equal to, or is greater than split point, we just change this to like yellow or something. I don't know, it doesn't fucking matter. And we'll take this into a function render histogram uncolored, right? And he's going to take in the context as well as the, I guess he'll just take in the canvas, fuck it. So we'll just do this as well. And then he needs the bar width to be passed in as well. And is there anything else in here? Split point? And data. You know what? Fuck this noise. This is too much work. For now, I'm just going to type return here. I'll probably regret this in a second, but let's just see. Okay. So what's it complaining about? Get element ID is null. Which element is null? Next. Oh, because I deleted the button. That would do it. Now what? Oh, there we go. What the fuck is going on? Console. Ah, body has already been consumed. Because this is split point response. Oops. Refresh. Okay. Oh, yeah. Hell yeah, okay. Okay. Okay! You know what? I might take that. That feels pretty damn good. Yeah, that feels like it's working. Am I crazy? Ooh, that one might not be good. This is a problem. Because I'm pretty sure that this hump is supposed to be bright. There we go, we'll try that. So I guess the failure there was that the smoothing range was too low. Okay, what do these like histograms even look like? There we go. Okay, so let's kind of stick them here. Okay, so I can see maybe there's a risk that if the smoothing range is too low, some of the like filtering won't work correctly. But otherwise, it seems like it's probably okay. I feel like for the most part, that looks about like how I would do it. Sorry, I'm not really saying anything because I'm just staring at this histogram selecting over and over again. Does anyone else expect the histograms to be a lot more peaked? I mean, without the smoothing, it might be. There's like some blurring going on as well as histogram smoothing, which is not helping, right? If we take out this blur, zig where is it? App.zig. And we take out the blur image. If we just do this, I think that'll do it. Let's just look. Refresh, 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 refresh. Nope. Why? I guess maybe we need the blur for it to work, but can we blur it? Less? It's probably the fucking... There's a bug in here somewhere. Just looking at the blurred even selector region, there does not look to be that large of a range of colors in there. But, okay, so unsmoothed, like the histogram, if we look at the size of this guy, this is only taking up half of the range, right? Which isn't really shown, right? This is the full range here. And like if we were just to look at like one dark section here, you do see like quite a short segment here. So I think it's like, I think that it's doing the right thing, but I've been wrong in my life. This is at 25 before when we liked it, and we had like, yeah, I think I like it like this. Okay. Okay. So now what? Now what? We have to apply this to the whole image. And maybe for now, what we'll do, the mass contained in the regions between the peaks is very large. The mass contained in the regions between the peaks is very large. Oh, I see what you're saying. Yeah, but I think that's just a result of... No, it's not even a result of smoothing, huh? Yeah, I see what you're saying now, actually. It does feel like the peaks... I get what you're saying now. You're like, this is two-tone. So why the fuck is there so much gray in here? And I do think that's a result of the blur. Right? Like, I do think that probably in here there is a lot of gray. I could be wrong, though. Yeah, I don't know where that's coming from. You are right that these feel very, very tall. It could be that the like with the noise in this area here, it gets kind of like we just end up with dispersed pixels. Seems possible. Did I just crash? I did. Fucking crashes. Okay. So let's pick maybe a smoothing parameter like this. So we have our smoothing radius as 5 for 25 iterations. And I guess now we can just apply, we can just make a binarized image. Apply threshold. I would expect 4 peaks in the dark light section. I think we do see 4 peaks here. We see this one here, this one here, this one here, this one here. There's a lot of gray, but I feel like the mass of the identical black and white should be larger. By mass, I mean function integrated. Yeah, I do. I get what you're saying now. I think I agree. Oh, fuck me, man. The thing is bugged if I don't smooth enough, so we can't really look that easily. Maybe we could just fix the bug. Yeah, I am pretty sure that it didn't look like this in the original image. In fact, what we can do is we can copy this image and we can open it in GIMP. If we open it in GIMP, we can look at the, oh yeah, here it is. Right, like this is the histogram of the unblurred image, like this, right? But as soon as we apply some amount of blur, right, the blurring does heavily affect, you know what I mean? Like here, this is kind of what you're saying, right? You would expect to have like 1, 2, 3, 4 peaks. But then as soon as we add like any amount of blurring, it like really degrades that. You know what I mean? And it could be, yeah, I'm just not sure. I'm not sure. I guess it's just that the mass in each of these peaks is actually quite small, and it's probably a result of like the way that the algorithm that we used to add noise is probably just doing something that's like a little unexpected. Would be my guess. No, I don't know what you mean to BH. Yeah, I guess I wasn't really saying words there. So I think what's happening is this histogram on the right here for the unblurred image. We have like 4 very narrow but tall sections. And these are saying like we have a lot of pixels that are this exact value. And then we have like a lot of pixels that are like this value underneath, but not like there's not a significant number of pixels at any given specific pixel brightness. Then when we blur it by using filters, blur, we're not doing a Gaussian blur, we're doing a box blur, but whatever, it's close enough. I think what's happening is like that peak is getting like copy pasted into a lot of bins around it. And so I think that, yeah, I'm not entirely sure, but I think it's just that like the slopes are softer now, and now the like height of the histogram is maybe normalized a little bit differently, and that's causing some form of difference, but that's a really good histogram for the unblurred version. Maybe we're just making things worse by blurring. I was worried that the noise algorithm wasn't indicative of real noise, right? Because we got here by taking like a really clean image and then applying noise on top. And I worry that in the real world, if I took a photo, it might not look the same. And so I kind of get what you're saying. Like, yeah, maybe we're making things worse by blurring, but I do think that it's worth it taking that risk. But I agree with you. Like, there's a chance that that's true. All right. So go back here. We said smoothing radius 5, num iterations 25, and let's just apply the threshold so we can get a look at it and be happy. You know. So we'll say maybe we'll replace blurred image here. Do we have a function already for extract binarize? No. So we will make this one. Extract binarized image. And we take in the image and the threshold. So this is going to be some usize. And no, a U8 it's going to be. And we are going to create a new image, which is going to, I think we have some code to do that somewhere. Wherever we call blur image, here we go. Call image from Luma. I guess we don't even have to, we already have an image, right? So here we can just say try, maybe we just apply it to the original. So we'll say binarize image here, and we'll pass in our image and our, what do we call it? Dark light partition threshold, dark light threshold. Okay. So this here is just going to be called binarize image, and he's going to be void. And we're just going to iterate over all the pixels. And if the pixel is above the threshold, is above threshold, image set x, y, 255. Else, set it to 0. Yeah, that should be it. Should be it. Here we will put the threshold here. And here we say like this, boom. Something about this is wrong. This doesn't go here. This does not go here. This does not go here. So this guy, we use him in the cluster finder. And after we do all of this, then we binarize the image down here. Yes, 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 yes. So here we binarize the output image. And with the self dark light threshold. There we go. And we just do that everywhere we use this cluster finder next. And again, this is a lot of duplication, wrong spots, whatever, but I just want to see the results before ending stream, so we're taking shortcuts and I'll clean it up later. I just want to see it work. Expected U8 find U size. We'll just int cast it and fix it later. Still no good. Expected error union type found void. Yeah, just this can't fail, which is nice. I'll take that. And one more, 423. This guy has to have an ampersand as well. Okay. Let's see it. Something about this is wrong. Fine. Fine. We will not use that as the output image. We'll use this as binarized image because I feel like we are fucking up somewhere. So somewhere we are going to say self binarized image is equal to output image. But we need to allocate a new actual chunk of data in this guy. How do I do I have like an image duplicate? I guess not, but I can just make one. We can just make one. So we can look at image.zig, and we can just add a little bit of a function clone. Takes in self and returns a new version of him. And he's going to return, this is, everything is the same except for the data. So we're just going to say, what is in this guy? Data is a U8 slice. So we're just going to say stood self. Do I have an allocator in here? I don't, which is fucking annoying. So we'll clone him with some allocator. And we will say alloc.alloc self data len of u8s. Yep. Yeah. Oh, this is also annoying. This is also annoying. I'm not going to do this. It just doesn't work out nicely. Because the abstraction's wrong. Because I took too many shortcuts. Okay, self binarized image is equal to self output image. Self binarized image dot data is equal to self alloc u8s of self output image data len. Yep. And then we mem copy from the output into the binarized image. And then we binarize our binarized image. Then hopefully that doesn't break anything else, and I just apply this here and here. Boom. Yeah. Maybe. I don't fucking know, man. Does that build at least? 152. Fuck. Oh my god. Ret here, ret here. This is awful. I know. But we are going to... I just want to see the answer. I just want to see it. So I just want to take as many shortcuts as I can, get angry at myself, and then fix it later. Do we build yet? No. 152. Binarized image you will undefined. Okay, so now I refresh. That's just the blurred thing. Nice. I apply my smoothing. And then, now we should be able to go to our server and add back in the binarized image handler. Which should just be... Right, image with BNP, get binarized image. Okay, I think everything here is in the right spot. Refresh. Apply my smoothing. And here, can I just go to this? Oh, hell yeah, baby. Okay. Let's apply all here. Okay. So that's definitely something. It's pretty clear that we've fucked up this and this. Like, we're leaning too close to light. So based off this histogram, maybe it is too smoothed. So let's try that again. It's still not great, huh? I guess you could kind of argue that because we are blurring it so much, it's hard to preserve the edges. So maybe we can blur it less. Let's just do 2 iterations instead of 3, or is that kernel size 3, iterations 1, maybe? We'll try blurring it a little less. Because you could argue that from the blurred image, we don't have enough info. Oh, and now at 248, we are crashing. Because if our clusters are empty, this is a problem. So we'll just say that here, we'll just say if dark cluster IDX is greater than clusters len, return dark max or something. I don't know. Doesn't fucking matter. We just need something. Still no good. Oh, this would be greater than or equal to. Oops. Oopsies. Okay, now at least we get here. Nice. Okay. And then go back over here, refresh. And let's try to look at something that we're going to recognize. Refresh. Okay. That looks about right. That looks about right. So what's interesting there is that, like... Okay. Say we smooth less. Okay. Refresh. Like, this is clearly wrong. Right? This is very, very clearly wrong. Okay. Okay. Let's see maybe along here. How's that look? Dark light, dark light, dark light, dark light. It's not great. But again, maybe you could make the argument that the blurred image isn't a nice place to start from. Right, like these 3 dots here. Let's at least put it on the same page so we can fucking see it. Fine. Fine. Fine, fine, fine. Let's put it on the same page. So, this is going to be binarized. And we'll look here, and we'll look at image binarized is image binarized, and binarized is this. Okay. Does that at least show us the 2 things next to each other? It does. Nice. Okay. And actually, we need to update this guy after we rerun the histogram. After we update the smoothing parameters. So I guess we'll just do it in render histogram because I'm too lazy to put it in the right spot. And again, shut the fuck up. We will do the right thing another day, another time. I just want to see something. Okay. So the question is do we believe that the thing on the right is a good representation of the thing on the left? Here, I would argue yes. Here, yeah, I mean, it doesn't look great, but I think it's because the blurred thing doesn't look great. Right? So even if I just take, like, this, and I try to look at the timing row, I think that we do see a pretty clear light, dark, light, dark, light, dark, light, dark, light, dark, light, dark, light, dark. If we look at this timing row, we have light, dark, light, dark, light, dark, light, dark, light, dark, light, dark, light, dark. Like, it's not bad, to be honest. I was pretty disappointed at first. But I think it just could just be that the source image is, like, too fucked up. And so this could be maybe good enough. Maybe. Let's see if we, like, adjust this at all. Like, what happens if we play around with these parameters? Oh, yeah, we could, like, drop the number of smoothing iterations. Let's try that. Oh, yeah. Oh, baby. Yeah, I don't know. It's not awful. This is a problem. So there's a little bit of thresholding issues where maybe the hump is getting put on the wrong side, which seems pretty crazy. So I think there's probably a bug in here. But other than that, it's not so bad. I wonder if we can take a look at maybe a different sample. Let's look at something else just to see. I've downloaded a few QR codes from the internet, and let's just kind of like, you know, take a look at that guy. Oh, hell yeah, baby. Look at that. Wait, that's so good. This is like a way cleaner image, right? But yeah, look at that. That's so fucking sick. That's like almost perfect. And that histogram has like a nice clean split What does this look like? I mean, it could be just the source data is like really good, right? But yeah, that's not bad at all. Not bad at all. Okay. I'm pretty happy with that. Pretty happy with that. I think that probably what I'm going to end up doing is I'm probably going to end up like picking a window size that's like somewhat local, and then probably like iterating that kind of chunk by chunk around like some smaller area and use that in some way. Not really sure yet. But yeah, I think I'm going to play this a little bit more off stream. And let's see, tomorrow probably, hopefully I get it to a point where I'm happy enough with it that we can start trying to look at, trying to like find the finder codes in these versions. I think that what we're going to have to do is we're going to have to like, maybe we can get away with completely axis aligned boxes still. But yeah, pretty happy there. So raid purple elf. Yeah, okay, sorry. I have been meaning to start hitting the raid button a little bit more. And by a little bit more, I mean at all. So I'll figure that out in a second. But before we do that, let's do our little plugs. So thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for 2 hours. We're working on this QR code decoder right now, but there's like a variety of other projects on like the linked YouTube and GitHubs. So if you want to see those, you can check them out. There's stuff like Rust operating system, neural network stuff, some like 3D geometry stuff, a little bit of web dev, some like zlib stuff, some diff tooling, just kind of like whatever the fuck we feel like, right? So if you want to see any of that, that's there. Or if you want to swing back by in the future, we're around. Yeah, if you're watching on YouTube, you should try swinging by on Twitch and saying hi, see what's up. I think you guys are right. We should try raiding. So how do we do that? We go to Twitch. We look for a channel to raid. You are suggesting Purple Elf. And I think that I've seen her a little bit in the past, so I'm down. How do we do this? There's a raid button. And we just type in Purple Elf. Nice. All right, guys. Enjoy. Go say hi. Don't be rude. Don't be weird. You know, just be normal. And I'll catch you guys on the next one. Do I have to wait till the raid starts before I hit stop streaming? I think so. So I'm going to hit the raid button and then we'll turn off. So thanks for watching, guys, and I'll catch you on the next one. Bye!